Okay, hopefully it's back up. Yeah, having some trouble with the settings in my in OBS. It and I don't know if it's the internet connection here. Internet connection where I am currently should be pretty good. So hopefully I'm not dropping too many frames. Um, anyway, I'm just going to keep going, and then obviously if the stream stops, then we'll have to try again another time. Anyway, I just created a virtual environment, and so I'm just going to go ahead and activate that. And we're going to pip install PyTest. And I'll be trying to do basically like a TDD approach. So we'll make a test directory. I'm going to touch a file that we'll call sentiment analyzers. And also tokenizers. Hey Tajudeen, thank you. So yeah, we'll move into our tests and we'll just start a new test file, I guess. Test tokenizers. Actually, I want to make this a Python file. Okay, cool. So we're going to have this test tokenizers. And now we're just going to spec out what we want a basic tokenizer to do. So the general process is going to be, we want to be able to take lists of strings and tokenize them so that we could perform other NLP tasks on them downstream, like sentiment analysis, or maybe constructing word vectors and that sort of thing. So we're just going to write some unit tests. And we'll make some basic English tokenizer. And we'll probably call that tokenizer module. Alright, so the first thing that we definitely want to be able to do is test that our tokenizer can test the tokenizer splits string tokens on white space. Okay, so we're doing TDD, so we don't have any code actually written to do this yet, but we're going to write a failing test and allow that to drive development of this particular class. So we can imagine that we might have some input string, which would be like foo bar baz or something, and then we're going to have some simple tokenizer object, and we could pass that to the constructor of this class, or the initializer of this class, but instead maybe we'll just have a method on it, like tokenize. So tokenizer.tokenize input string, and that's going to produce some output tokens. And we're going to expect that to produce the list of tokens foo, bar, and baz as strings. So our expected value here would be like foo, bar, and baz. And then we're going to assert that this expected list of tokens is equal to the tokens that we get out of our tokenizer tokenize method. So if I run this test, oops, this is not a test file, so I wonder how we convince it that it is a test file. We'll go ahead and pip freeze. Make sure that PyTest is installed. Tokenizers.py. Oh, I think I should rename that to test tokenizers.py first of all. Like if I just run PyTest here, we'll get our failing tests, but I want to try to run it from within Vim as well. Okay, there we go. So simple tokenizer is not defined. That's because we haven't made it yet, so we can go ahead and make that. I'm going to go up a directory into the tokenizers module and make a simple tokenizer object. And yeah, I actually want to make this tokenizers.py. And let's see what I've done here. Yeah, tokenizers.py. So we've got this simple tokenizer object. And for now, we'll create an initializer and just pass. And we'll go back to our test. And we'll go ahead and run it again. And name simple tokenizer is not defined. So let's go ahead and import the tokenizer that we just made. So from tokenizers, import simple tokenizer. And we're going to get an import error here, I think. Simple tokenizer has no attribute tokenizer. Actually, it imported fine because it's in the same directory. If I wanted to clean this up a little bit, sentiment. What I'd probably do here is actually we're going to remove tokenizers and remove sentiment analyzers for now, and then we're going to move that the actual tokenizers class out of tests so that it's here. Okay, looks like the stream is still working, so that's good. Cool. So now what I'm actually going to do is source CMD, bin activate the virtual MD again, and what we're going to do is pip install editable this directory so that we need to create a setup.py file as well. So we're actually going to install this module as we work on it. This will be from setup tools, import setup, and find packages. And then we're just going to call setup with the name of this package, I think. I may have to look up the args here, but I think it's name, and we can just call this simple sentiment analyzer. Version, we can just do 0, 1. And then packages will just be find packages. Very cool. So now we should be able to pip install this directory. Method object is not iterable. Check packages. Is there anything wrong with our setup file? Setup. Oh yeah, that should be a method. Obviously. Okay, cool. Now we should be able to install the directory, and finally we can get back into our tests. Okay, so we'll run the test. We see that simple tokenizer has no attribute tokenize, so we'll go back into the module. I'll just do that in a new buffer here. So we got to make that method basically. And we know that it's going to accept some string input, so we can call that a sentence. So this tokenizer, this tokenized method will take in as input a sentence string, and it's going to output a list of tokens. In the class for a docstring, we can just say like tokenizes or handles the tokenization of strings into token strings. Okay, cool, so it's a good start, and then if we go back to our tests and run the tests again, we get an actual assertion error this time, so we can see that the expected string of tokens is equal to none, and we want it to actually equal the string of tokens, obviously. So simplest way to do that here would be simply to return sentence.split, and that should split the sentence on white space. And so now we get a passing test. Obviously, we're going to need our tokenizer to do more than simple white space splitting, although that is sort of the biggest, sort of the central feature of a tokenizer. But I think that there are more use cases that we're going to want to handle. So for one thing, we should want to downsample the number of possible tokens that we generate. So for instance, if we have a string that says like foobar baz with some capital letters in it, we would still want it to tokenize the same value. Because semantically, if we're trying to extract some information from the text, we don't want to discern between the variations that we would have with capital letters versus non-cap. So if I run this, we're going to see we get an error because our tokenizer just split on the white space and didn't do anything to actually modify the tokens. So we can go back and we can change this up a little bit. So tokenize method right now is basically just returning that string split on white space. And so what we can do instead is sentence, we can just lower it first. I think that's the syntax. And so that should get, yeah, we get this test to pass. In fact, I should be running all the tests. Okay, so that one passed. Keys are too loud. Thank you for reminding me of that. I'll try to type softer. For some reason, like the keys on this laptop are super loud when I'm streaming. And I'll definitely try to upload the video for later. Okay, so I'll try to type softer. Alright, so we've got these two tests. And I want to check out how to run all the tests at once, and I can't remember exactly how to have that bound. So I'm going to go ahead and edit my vimrc. Test all should be A. Test file should be capital T. It's interesting that it's only running one test here. Oh, because I haven't changed the test name. So split string tokens on white space. Yeah, we'll just say case insensitive here. Okay. Cool. So both of our tests are passing. Now we want to make sure that we maybe get rid of special characters for the time being. So things like punctuation. Let's start there. So we'll say like our tokenizer removes non-alphanumeric. Cars. So if we have the same sentence here with some exclamation marks in it, and some question marks, some other characters, we would still expect to see this as an output. And in fact, if we run this test now, we'll see that it fails because we're not doing anything to handle characters, special characters. So go back to our tokenizer. And yep, so right now we're just splitting string text on white space. We want it to remove special, or we'll say non-alphanumeric characters. So if we want to only return alphanumeric characters, probably the most straightforward way to do that is to use regular expression here. So we can import RE. And so we want to take this sentence to begin with, and we want to substitute any non-alphanumeric characters we see with an empty string, so that it will have the effect of removing them from the input string before we tokenize. So what we can do is say like clean sentence is equal to re.sub, and then we'll write our regular expression here. So we'll get a capture group where we say it's not equal to alphanumeric characters or spaces, and then if any of that's not the case, then we're just going to return it with empty string here. What have I done? Here we go. Okay, for the input sentence, so I think that's the structure of sub. Yep, and then we're going to return this time clean sentence to lower. We could simplify this a bit. Maybe if we lower it first, and then our regular expression only needs to look for A through Z, 0 through 9. So we can say like lower sent is equal to sentence.lower. Clean sentence is A through Z, 0 through 9 for lower sent. And then we'll come back here and we'll say, we'll just call this lower sent. Then clean sent, we don't need to call lower here, and we can just split. So now we can run our test here, and clean sentence is not defined. So what do we mess up there? Oh, clean sent. Okay, did it not save? Okay, cool. So now we have 3 passing tests. Obviously, it's still extremely simplistic. For instance, if we have some special characters, even not so special characters, just characters that aren't sort of ASCII in the alphanumeric range, we're going to not be able to tokenize properly. But maybe we can handle that in a little while here. The next thing maybe that we'll do is we will want to remove stop words from the sentence that we pass. And so all stop words are words that don't really add any semantic value to the sentence, so they don't add any meaning. And so we'll test that our tokenizer removes stop words. So if we have something like a foo, that bar, Baz, and for Baz or something like this, we still want to return the same expected list here. And if we run this, you can see that our list of strings has all of those words in it, many of which don't add any meaning. So like a and that, for, that sort of thing. So I think what I'm going to do here is just look for a list of stop words somewhere. Let's see, English. We can look on GitHub. Hey Albert. Hey Sean. See, NLT's English list of stop words. This is from NLTK. So NLTK is a pretty popular set of tools for natural language processing in Python. Yeah, I think that the list of stop words is probably a bit bigger than that one. So let's see if we can find another collection. Cool, stop words English. And this is already as a list. I'd like to find a file. Yeah, sorry, this is what we want, I think. So there's a bunch of words here. They actually include punctuation. Maybe we'll edit our tokenizer to allow for quotation marks. So all I'm going to do is curl this down into a folder here. So let's go ahead and make a maybe like a word list or like a resources folder or something. We can make a resources directory. Resources, and then we'll just scroll down what we just found here. Connection refused. I think I'm on public Wi-Fi here, so probably trying to think of a better way to get this down. I could just save this actually. We could go into projects, simple sentiment, resources. I'll go ahead and save it here. Okay, I'm going to move this just to say stop words English. Okay, so it looks good. Except there's a % sign down there, so I'm going to go ahead and try to clean this up a little bit. Actually, it looks good. Okay, so we cleaned up our list of stop words, and now what I'm going to do is actually I'm going to create an environment variable in our virtual env. So we can actually just vim, where's our virtual env bin activate, and so there's going to be this activate script in here that was generated by virtual env. And so what we can do here is actually export another environment variable. So I'm going to go ahead and export, we'll call it stop words list, and let's go ahead and we'll just save the path to it. It's going to be here. Simple sentiment slash resources. I think it was just stop words. En. And you can just check on that. Resources stop words en. Yep, that's correct. And then we're going to want to unset that whenever we deactivate. So we'll look for the deactivate script, which is here. And we can basically just unset stop words list. Okay, sweet. So now if we go back into our tests, go ahead and run this. So we're not removing stop words, that's the test failure. Actually, I forgot we need to source env bin activate again. And now if I go ahead and echo, or actually if we can just look at the top of the stop words list, you can see that we have them available as an environment variable. And so what I'm going to go ahead and do now is go into tokenizers.py, and in the initializer of this class, we could do this any number of ways, but I'm going to say that this class has a list of stop words, and we can get that from the environment. I think that's just os.environ.get, if I'm not mistaken. I need to import os, and we'll import stop words list. And I could write a unit test for this to make sure that the stop words list is available. It's almost like an integration test because we actually need to have the file on disk and then assigned the file path assigned to this environment variable. Anyway, let's go ahead and implement it. So we've got self.stopwords is equal to, actually that's just the path. So we'll call this the stopwords path. And maybe what we can do is actually, instead of that, we'll say self.stopwords is equal to self.getStopWords. And then we'll write a function that returns them by opening that file. So get stopwords. Okay, so we get the path, and then what we'll say is like with open, this doesn't need to be a class attribute anymore, with open stopwords path, typing type as F. What we want to do is say, like, for each line in that stop words list, for a line in F, and actually we can strip, is it trim or strip? I think it's strip. For each line in F, what we're going to do is add that to our stop words. We could change this to use list comprehension as well, but for now we'll just say stop words dot append line dot strip, and then we'll change the iterator here. So for line in F, stop words dot append line dot strip. So strip is going to remove like the new line that's at the end of every word in that list. Check on the chat really quickly. Avamesh, yeah. I should get back to making more .NET videos soon. Just been really busy with work, and I thought doing some live streams for a while would be a way to kind of get back in the rhythm, making videos and stuff. So definitely let me know if there are things that you guys would like me to make videos about. Certainly I've got a lot of requests to finish the identity server stuff, which I started in the spring. So yeah, definitely I'll work on getting that finished up, maybe within the next month or two. And yeah, maybe if there's anything else you guys would be interested in seeing, just let me know. Okay, cool. So we've got this. So what are we doing now? So we get this list of stop words from our environment variable, and we open this file, and for every line in the file, we append a list with that word stripped of any new line characters. And so now in our tokenizer, if we want to remove those stop words from the list, what we can do is we can return word for word in cleaned sentence split if word not in self.stopwords, I think. My logic might be wrong here. I think my syntax might be wrong here. But let's run the test. So run this test. Argument of type none type is not iterable. So what is actually none here? CleanSent is this word for word in cleansent.split if word not in self.stopwords. Let's make sure that this is actually working. We initialize this class. So if we print self.stopwords here, and actually what I'll do is I'll just split this in a split screen here. Say from, actually I need to activate source. From tokenizers, import simple tokenizer, and then we'll make one. We should see it print if we have a list of stop words here. Okay, so it's printing none, meaning that we obviously don't. I'm going to keep this open. I'm just going to resize it. Okay, so clearly get stop words is not doing anything. That's because we're not returning anything, obviously. So we open this, and then we need to return stop words. Okay, cool. So I'm going to close this pane, and close this pane actually. And now we'll go ahead and go back to our tests. And we'll go ahead and run this test. Okay, so now we get everything passing, so we'll make sure all 4 tests are passing. So now we have a very basic tokenizer. We're removing stop words. We are removing non-alphanumeric characters. And we are lowercasing any of the tokens that that come into our list. Something that we can also do here to sort of increase test coverage here, and kind of we want to cover like edge cases, is to import PyTest, and then we're going to do PyTest parameterize with the decorator here. So we can say pytest.mark.parameterize, parameterize actually, and if I remember the syntax correctly here, we want to have, actually I kind of forget the syntax. I think this is like a list or a string list of something like input expected or whatever, and then we want to have a list of tuples here with input and expected values. So if the input is like foo bar baz, the second argument in this tuple would be what we expect to come out, which was foo bar baz tokens. I'm not sure if I got that correct. If not, we'll just look it up. But so now I've got input and expected here, and we can get rid of this. I'll call this input and then expected. Okay, yeah, that's how we use it. So if we want more test cases, we can just add them to this list of tuples here. So like foo bar baz, and then like in the case where we just have foo baz, it would be like this, and then if we run this, we get two passing tests. So let's try to write some edge cases here, maybe. Like if we pass it empty string, we should get like empty list back, for instance. If we pass it just numeric characters, we should get numeric strings back, actually. Okay, cool. So that's an easy way to write different sort of test cases and parameterize them, so you don't need to actually write like a whole bunch of extra unit tests if you're testing sort of the same behavior with different types of inputs. Hey Ronnie, thanks for the input. I definitely have had a lot of requests to continue Identity Server, and I'm definitely going to carve out some time for that and try to wrap up that series. I kind of miss writing C#, so it would be a good opportunity to get back into it. Okay, cool. So we did some white space stuff. Maybe we could parameterize this as well. So maybe the way that this one will work is we'll write a couple of tests with like white space at the beginning, at the end, or sorry, this is case insensitivity, right? So if we do like something like this, we could use the initial use case that we had in here, where we have like some caps and some lowers. Now we just replace this with input, and we have like an input and expected here. Okay, one failed, and actually we're printing out all of the stop words now, I think. Foo baz, input expected. What is wrong with this one? Let's see. Foo is not equal to foo. It's interesting. Oh, in the expected, yeah. There we go. We want this to look like that. And this is the input side. My mistake. Okay, cool. So that passes. And then I'm going to remove this print stop words from our simple tokenizer initializer. Run all the tests. So we have 8 passing tests. And now we'll just go ahead and increase the coverage of our logic here a little bit in the non-alphanumeric case. So, like, we did just special characters. We know that we're replacing special characters with empty strings, so we should get a single token with an empty string here. oops, function uses no argument input, so we need to make sure that we adapt this function for the parameterized method. Input expected, and go ahead and fix this one. Okay, actually we get empty list. And that must have to do with the order in which we are tokenizing. So what's happening here is we lower the sentence that should have no effect on special characters. When we're using the regex substitution, we're substituting everything with empty string, and then we're counting word for word if word not in, stop word. Since we just have empty string here, when we do this list comprehension, we call split, we don't have anything. Like, so this just ends up being an empty list. Okay, cool. We'll just do another simple one here, like store should just have store out. Oops. What have I done here? Oh, we need a comma. Okay, nice. Okay, and then the last one, what are some edge cases here? Well, what if we have only stop words, for instance? So first of all, we'll put in the first test case that we have, which was a foo that bar and for baz should just return foo bar baz. Now what if we have like only stop words in an input, like a and he where to go? I think that this should be empty list. I don't know if go is a stop word or not, but I think the rest are. So like pronouns and auxiliary verbs and articles, that sort of thing. Input expected. Okay, cool. So we get that. Now if we test the whole module, so we got 10 passing tests covering the basic logic of a really simple English sentence tokenizer. So yeah, so I think that's a good start to use for maybe downstream processing in a simple sentiment analyzer. I think I'm running low on batteries, so I'm just going to plug in. And I've probably got about half an hour left with this room that I've reserved, so we'll see how much of a sentiment analyzer we can knock out in like 20 minutes. Okay, cool. Alright, nice. So let's go ahead and we'll quit this. And what do we have in this directory? So I'm going to go ahead and make a sentiment analyzer.py module. Oops. And inside of tests, we'll write a new set of unit tests for the sentiment analyzers. Okay, looks like the stream is still healthy, that's good. So what I'm going to do now is we need to sort of spec out how we want a simple sentiment analyzer to work. And since I only have about 15 or 20 minutes, let's just write a simple rules-based sentiment analyzer so that after we tokenize, we're going to have a list of words, and we'll do something like just simple sentiment polarity, so like how positive or negative a sentence was based on like a strict lookup of the words that are in the list. So if I had some sentence that was like, it was a good day, we know this is going to get tokenized and probably will be left with like the words good day. And one of these words is neutral, like the word day, so that's not really going to affect our score. And the word good will say, since it generally has positive sentiment, it will sort of plus equals 1 the sentiment of this set of tokens. And maybe as a starting point, we'll just have like a really simple sort of dictionary lookup of, or even just a list lookup, and then if the tokens, if the intersection of the tokens that are in our positive words list with the set of words that we've tokenized is positive, then we'll increment the score of that sentence. So a positive score will be a positive sentiment, and a negative score will be negative. It'll be very crude, sort of non. Well, we won't be doing any machine learning or extracting like word vectors or things and doing some type of statistical inference. We're just going to be doing basic lookup on the words. So let's start by writing some tests anyway. So we'll write a class. What do we name our class? Sentiment analyzers. So our test class will be test sentiment analyzers. This doesn't really need to be an object. In any case, we'll say that like the sentiment polarity of all positive tokens should be positive. So that's a pretty simple concept, I think. So this is sort of like in the extreme case where given some input of, well actually it's going to receive a list of tokens, our sentiment analyzer will. So if we just have some input that's like good, happy, wonderful, and then we have some sentiment analyzer, which we'll just call SA. And we say we have some method on it. Maybe that's like score the input, and we get the output here, which we'll just call like what can we call this? Like it's the metric that is positive if something is has a positive polarity. So we'll just call it score. And we basically want to assert that the score for this set of tokens is positive. Okay, so I'll write a docstring here. If we run this test, name sentiment analyzer is not defined, so we can go ahead and do that. So we'll write our class sentiment analyzer. Make an initializer for it, just pass, and then from sentiment analyzers import sentiment analyzer. Okay, cool. So we'll run our test again. Sentiment analyzer is not defined. I think I need to go ahead and not mean to close that, but I think what I need to do now is actually pip install with the new module. So we're in our virtual env, and we'll just go ahead and pip install editable this directory. Okay, cool. We can go back into our tests. We'll rerun it. Yeah, so now we get a more interesting error, which is that the sentiment analyzer object has no attribute score. So we'll come here and we'll make a method. And for now, we'll just pass. And our sentiment analyzer here basically has the responsibility of like predicting the polarity, the sentiment polarity. Good, bad. Score of a list of tokens. Okay, cool. So we run the test. Now the error is that score takes a positional argument, but 2 were given. And so the way we've sort of coded by wishful thinking is to say that this score method is going to take an input list of tokens here. So let's go ahead and edit the signature. So we'll say tokens here. And now we run a test, and we can see that score was none, so we get a type error here saying that positive is not supported between instances of none type and int. So we need to do something to actually make it such that when we give it a list of tokens, we get some integer output when we call score. Obviously, if we were to just return 0 here and run a test, we'll see an actual failure saying that 0 is not greater than 0. So we get a more interesting assertion error. But let's think about how we would now actually generate this score. So we've got about 15 minutes. I think the best way to do this would be to basically look kind of like we did with the, it's going to take forever to index, but kind of like we did with the sentiment analyzer, or sorry, with the tokenizer. We got this list of stop words and basically just read from an environment variable where we had the path to those stop words, and then we loaded them into a class attribute here. Well, we're going to do something really similar in in the sentiment analyzer. So let's see, how quickly can we get this done? We'll say we'll have a positive words, get positive words, and we know we'll have one for negative words as well. Okay, and then we'll go ahead and make those methods. Oops. Okay, cool. So how are we going to get a list of positive and negative words? Probably the best way to do that is to go to GitHub and look for positive words. GitHub is pretty cool for finding interesting lists of things. So this one looks pretty good. So we could curl this down, but the Wi-Fi that I'm on currently doesn't. It has like port 80 blocked. So what I'm for GitHub here for some reason. So I'm just going to go ahead and download this like we did the last one, and we're going to call it positive words. Oh, that's good. Let's see if we can find one with negative words, probably from the same repo. Oh, this is actually a gist. So let's look up GitHub negative words. Okay, there's no gist. It looks like it's of the same format, so it's probably from the same lexicon. Yeah, so we'll go ahead and download this one as well. Negative words. And then, how much time do we have? About 10 or 12 minutes. So what I'm going to do is in a new pane, what I'm going to do is vim in activate. We'll go back into our activate script here, and I'm going to create two more environment variables here, one for pause word list and one for negative word list. And we'll set those here. Actually, this is in the deactivate, so we need to come down here. And I could put this at the bottom of the file, probably where it would be easier to find, but for now we'll put it next to the stop words list that we had earlier. And this would be pause word list and negative word list. And these are in our resources folder at negative words. Okay, cool. This just keeps file paths out of the code and in our virtual environment. So we'll go ahead and save that, and then we can close, and now we'll source env inactivate again. And yeah, if we echo or if we just head out these words, positive words list, no such file or directory. positive words. So we need to fix that, obviously. So we'll go back into script. Positive dash words.txt. Oh, I did underscores. Too much Python. Okay. Source again. And if we echo again or head, we can see that we get kind of a messy file here. So let's go ahead and clean that up. Okay, so we'll clean that up, and we'll do the same for the negative words. Just removing the sort of crone at the top of this header here. Negative words are pretty funny. Zombie, wrinkled, wrinkles, wrangle. Some of these things don't seem particularly negative, but it's cool. Alright, so now if we go back into our tests, and we'll test sentiment analyzers again. Run our test. We have a failure here about taking no positional arguments. So let's go ahead and start fixing our actual code. So when we get positive words, what we're going to do is with positive word list. So we put os.environ.get positive word list. So this is just a path. Import os with open positive words as f for a line in f. Positive is going to be words.append line.strip. So just like we did previously, actually this is really could be written as one function here. So we could just say like positive words is get word list positive. Negative words is get words list negative. And actually maybe we'll just do it by the environment variable. That way we can parameterize get this function get words. Get word list self path, and then we will simply open up that path with open words. Oops, I can type word path. As if we do this, and then we return the words. Okay, how much time do I have? I have actually a little bit more time than I thought. I think I'm getting kicked out of here at like 1 o'clock, so we have like 20 minutes before I need to wrap it up. Alright, so we're getting this word list from an environment variable, and we're just pushing everything into a list. So we have two sets here, and when I get some tokens, what I want to do is return some score. So if I'm just thinking about it, we start out with a score of 0. What I can do is plus equals 1 for each word if word in positive word list. So how would we write that? We would say for word in tokens, if word in self.positive words, we can score plus equals 1. Interesting to note here that the positive and negative words may or may not be sets. So like, I'm not sure because I haven't actually compared the two lists to see whether or not if a word is in, or if the two lists have exclusive tokens, in which case, like, we could cancel them out by having two if statements here, or we could do an elif and assume that if a word is in the positive list, that we don't need to check the negative list. But that'll be something for another day. Negative words, and maybe I will continue this series. Return score. So we could write this probably a little bit cleaner, but this might be a good start. We'll write a doc string later as well. I'm not going to worry about the doc strings for probably the rest of this one. So if we run here, expected string bytes are path-like object, not none type. So with open words path as f, so it looks like it didn't return the path. Let's make sure that I'm using the correct environment variable. We'll activate the virtual environment, and we'll go ahead and it's pause words list, so that works. Oh, yeah, pause word list. So that should be correct. We pass it the path, os.environ.getPath. So I'm wondering if I just didn't source activate here, and let's just see if that's the case. Okay, we're still getting type error, and it's still saying that words path is none. So let's try to figure this one out. Let's see. Oops, sorry. So we'll go into our sentiment analyzers, positive word list, negative word list. Does anyone see what my error is? Hey, Eduardo. Yeah, let's see. So if I jump to the REPL here, and I import os.environ.get pause word list. How about x is equal to that? So actually it is none. Am I exporting it correctly? Positive word list is equal to users. Did I change this? Resources, no, negative words, positive words. That should be getting exported. Oh, I'm an idiot. Pause word list. Actually not exporting it correctly. Negative word list. It's copy and paste error, classic. So now source env bin activate, and now I should be able to do the same here as well. Okay. Okay, built-in function or method is not iterable for word in tokens. So this is actually a good error here to look at. So we're getting to the point where I say for line in F, we're saying here for word in tokens. Okay, good. So now we need to look at our test actually, I believe. So we're bringing in some input here. We have a sentiment analyzer newed up, and then we call score with that input. And so the error that we're seeing is that built-in function or method or object is not iterable for word in tokens. So what is tokens here? That should be our input. Oh, I have a typo. And input maybe is a built-in or something? I don't know. All right, good. So we have a passing test. In fact, we may want to assert that the score is equal to 3, assuming that all 3 of these words are in our positive words list. 1. So it may be good, happy, and wonderful or not, but I doubt it. In fact, if we have good, good, and good, we're still getting a 1 here. So what is happening in our tokenizer? For word and tokens, if the word is in positive words, we're going to plus equals 1 the score. LF for words in negative words, we're going to minus equals 1. It's another typo here. And then we're going to return score. So what is happening here? We run our test. The score that's coming out is 3. So let's try to figure out what the error is here. We start out with a score of 0. We look at each word in the tokens. We say that maybe we want to say else. Continue. What else do we need to do here? Basically, let's print tokens and see what's coming out here, just to make sure that that's getting passed correctly. Good, happy, wonderful. Oh, I'm missing a comma, and that was the error. So, okay, syntactical error. Remove this. In fact, I don't think we need to continue here. We can check by running the test again, and we can see it passes. All right, cool. So we have a few minutes to write like the negative. And we could say bad, horrible, pathetic, and assume that those are all in our negative words list. And yeah, so we get that pass, and we get 2 passing tests, or 12 total for the simple sentiment analyzer and tokenizer that we built. All right. So obviously this is a totally rudimentary and pretty naive implementation of a sentiment analyzer, but it's interesting, in that it's probably a pretty good start for doing very basic sentiment analysis. And maybe next time what we can do is something I like to do is, rather than sort of take this tokenizer and the sentiment analyzer to the next level, which we could certainly do in the future, maybe we should try to apply it to like a real problem first, and then we can sort of firsthand observe some of its limitations. And then when we do that, that's going to help us figure out like specifically what areas it's lacking in. So we'll see the types of sentences that it doesn't properly characterize, for instance, or on the types of tokens that it misses out on. And that can sort of drive our process for improving these modules. So maybe we'll keep this going. Yeah, and try to keep it going with TDD. That's kind of a fun way to do it as well. Maybe we can write one more test here before we go, because I think I have like 5 or 10 minutes. We also want to assert that the of like net neutral words should be negative. So if we do pathetic, horrible, bad, good, nice, and positive, that should net out to 0. So that's cool. We can think about a few things just off the top of our head, though, like that. A few things that come to mind with this are that like every word here in our word list is plus equals wanting some score value. but it's also the case that some of these words have sort of a higher or a lower polarity in either direction. So like good is maybe like +1, whereas like exciting or ecstatic or tremendous would be more like +2 or +3. So these words sort of conceptually live on some type of scale. And so maybe we can think about how we would assign different values to different specific words, like using a dictionary or creating an object for that. But you can already kind of think about the fact that the meaning of words is really contextual. Like bad does not always mean bad. Like if someone says something is badass, like doesn't mean that it's a negative thing. So you can see that like this rule-based approach is going to be inherently limited, and so eventually we're going to want to do something like pull out the semantic value of these words using some contextual analysis, like using some statistical analysis like word2vec or global word vectors or some other type of embedding. So that'll be fun. We'll probably eventually get there too. But yeah, this is something fun to do just as a start. So I hope you guys enjoy the stream. Be sure to leave comments here. I'll try to make sure this video gets posted to the channel so you can watch it if you're interested. Maybe it's totally boring. I don't know. But in the meantime, I'll keep trying to make videos, and it's good getting back on YouTube. So see you later.